Here we have problem number 26. At the construction site, 62-kilogram bucket of concrete hangs from a light strong cable that passes over light friction-free pulley and is connected to 84-kilogram box and horizontal roof. The cable pulls horizontal on the box and 48-kilogram bag of gravel rests on the top of the box. The coefficient of friction between box and roof is given. Find the friction force on the back of gravel and on box. Okay. The gravitational acceleration is this one. Okay. Find the friction force on the back of gravel and box. Okay. So basically we know that when the gravel was not on top of the box, it started sliding down. Okay, so in order to stop that one, they put extra weight on top of the box. Then it has been stopped. Okay, so we have to find the friction force, okay, between gravel and the box. So first of all, we know that it's not moving. If it's not moving, then acceleration is 0 and force is also 0, correct? So therefore, to solve such a problem, we have to consider two parts, this one and that one. So let's first consider the bucket itself with concrete. We have two forces on that one. One will be the mass of the bucket times G, and then we have tension. To solve such a problem, we have to use Newton's second law, where sum of the forces is equal to ma. Now, since object is not moving, the acceleration is 0, okay? So therefore, this acceleration becomes 0. Thus, you will end up with mass of the bucket times G minus tension is equal to 0. And we know that mass of the bucket times G gives you tension. And if you plug the numbers, you will get that tension is equal 607 Newton. Now this is a basically friction force, which minimum friction force that is required to hold the bucket from movement. Okay. Now, if you try to calculate this one by itself, then we know that we have normal force, we have friction force, and then we also have this friction force between them. And if you try to calculate total friction force between all these two masses, then you will get from this equation, you will get that it's equal to 1293 newtons. Okay, so in order to stop this bucket from sliding, minimum friction is required will be 607 newtons. And this is actually big greater than this one, which is also fine, but we are looking for this one, okay, which is minimum friction force that can stop the bucket from movement. Now, in the next question on the problem number 27, it says that when they remove the gravel from the box, the bucket starts moving down, okay, with an acceleration a. So in that case, what we can do it, how we can calculate it. So object is moved initially from here when v initial was equal to 0, and it moved it to a distance of 2 meters, and we have to find what will be the v final at 2 meters. Okay, so again, first of all, we have to look at the bucket itself, and we have to come up with equation using the Newton's second equation, which is sum of the forces equal to ma, and this the weight of the bucket, which is mg here, mass of the bucket times g, and negative of the tension because tension is opposite direction, and then that's equal to the mass times acceleration. So this mass is actually the mass of the bucket, okay, mass of the bucket times acceleration. By doing so, let me highlight it, just that this is our first equation from the bucket itself, this one. From there you can calculate what will be the tension here. The tension is equal MBG minus MBA, okay? Then we have to look at the box itself. So again, you have to draw feedback by diagram. This normal force, this is M box G, this is tension, and this is your friction, okay? Using the Newton's second law, we can say that tension is on the right side, so it's moving to the right. So therefore, I made it tension minus friction, kinetic friction. Then that is equal to the mass of the box times acceleration. So you can take this tension from equation 1 and you have to plug it to the equation 2, okay? When you do so, you will get this equation. From there, you have to calculate what will be the acceleration, okay? You do calculate it, and you can calculate it, and you can find the acceleration, which is equal to 1.85. And then you come to the third equation. In the third equation, you have to use kinematic equation where V finals squared is equal V initial squared plus 2AD. Since initial velocity is 0, since it was not moving, then from there you have V final, and whatever you got from acceleration, you plug it here, and then you can find that V final at 2 meters will be 2.72 meters.